Hi, I'm Christine. Welcome to this talk. As a disclaimer, I am one of the co-founders of Honeycomb, and we practice what we preach, but the techniques talked about in this talk should be applicable no matter what tools you use. So, let's set the scene. Quick question, only mandatory audience participation in this whole talk. Bear with me. How many of you identify primarily as DevOps or infra or ops? Show of hands. Okay. How about, okay, that's not for me. I primarily identify as a developer. Okay, good. There'll be a little bit of something for everyone. My name's Christine, and I'm a developer. When I first started out, I was young and excited, bright-eyed, bushy-tailed. I took pride in being very fast at what I did. I could take a spec, do all the responsible things that the software engineer did, and commit and ship. And I could do it over and over again. And it actually took me a few years and a couple jobs before I interacted with my first real ops person. I met her because I was working on a new component of a system. And that nice little rhythm I'd gotten in my first few years, where I was just fast and moving and committing and then moving on to the next thing, started to look a little bit more like this. There's a lot of door knocking on, metaphorical because this is an open office, but door knocking on and frustration. And I started to learn why certain unflattering stereotypes of engineering roles exist. Because I would hear things like, from the other side of the room, cranky person having to deal with my code going to production and breaking things. And I would get defensive, and I'd be like, well, you know, it worked when I wrote it, so it's got to be your production machines. And as time went on, and my relationship with this ops person improved, it became clear that, you know, after all, there was a little piece of responsibility that I did have to take. That often these small, totally safe changes I was pushing to production were causing some chaos out there in the wild. There was a really great Medium post in February published by an engineering leader at Expedia where he analyzed several hundred production incidents, went through all these postmortem reports, looking for not root causes, but triggers, the things that caused an incident to surface. And this big orange slice is change. Change in the code, sometimes change in the config or infrastructure, but change. And we've just established who the agents of change often are. And on a macro level, things are changing around us, right? The like very simple, nice, neat lamp stack of Rails, Rails' heyday, is starting to look a little bit more like the diagram on the right. We've got more pieces, more interactions, and as a result, the number of possible ways that an interaction might go badly and things might break. And so in this new, more complicated world, this old pattern of, well, devs write code, and then they throw it over the wall, and ops folks have to deal with it, that model starts to break down. And the thing that we're starting to have to see is that these two sides of the wall have to work together, have to think about, well, what happens when my code hits prod? Well, what sorts of things can we tell the developers so that they write better code in the first place, and their code works as well in production as on their machines? And so if the first wave of DevOps was having ops folks learn to code or automate their work, the second wave is going to have to be to support this migration that we're already seeing. It's going to have to be to have developers learn how to own their code in production out there in the wild off of their own machines. And that little bridge between the two, the way we start to blur those lines, it's observability. For anyone who may not be familiar with that term, there's an old school engineering definition. You can find it on Wikipedia. There's lots of cool stuff about it and how it helps in things like space flight. In our modern software engineering world, I like to think of it as instead, well, being able to ask questions like, what's happening with my software Why is it behaving in this way? So, OK, wait. If developers are the ones causing all the problems, why are we setting them as the protagonists of this story? Well, a lot of the right instincts are in place. Let's take a look at standard-ish modern software development process. There's so much thought and curiosity going in to make sure that we're writing the right thing. And a couple things might jump out at you, notably how many times the concept of testing is introduced. We do it over and over again as the environment gets more complicated, as it goes from kind of nice, neat little unit tests all the way to full integration tests. We could also argue that this last one is also a form of testing. Traditionally, on the ops side of the spectrum, traditionally, where the ops person is looking at production and saying, this doesn't look right. But it actually shares a lot of similarities with the testing that we do in pre-production. Writing good pre-production tests, right, is all about thinking through scenarios, thinking about how our code should behave, and then investigating when it doesn't do the thing that we thought. The more practice we get at this, the better our code gets, because we're better at thinking ahead, explicitly stating our assumptions for how our code should behave. But the static tests tend to run in these nice little neat environments. Cases don't change a whole lot. And so they cannot capture the unpredictability of production, of real-world users, malicious or otherwise, doing crazy things on our system. And so in order to extend this method of comparing expected versus actual to production, we tend to look at things in aggregate. We tend to look at things at a high level, but the concepts are still there. OK, well, I expect it to look kind of flat and stable like this. When the actual jumps up, why? Imagine writing code expecting it to behave like a Miko, and instead getting a rocket. All right, we've got some investigating to do. To give you a sense of where we're trying to go with this, I have some tweets from CJ Silverio, who put forth an initiative recently within her engineering team to prioritize observability. She did some great work, her team did some great work instrumenting a legacy monolith, and suddenly realized what it was like to be able to see. And the main thing that she heard is that this thing that people had been scared to touch, to make changes to, or to improve, suddenly wasn't so scary anymore. The more you can see what's actually happening with your code, the lower that barrier to entry feels. And that same thing happens between dev and prod. By embracing observability, we can start to see how the code that we understand in this nice little sanitized space behaves out there, and we can start to plan for that as we write the code in the first place. If we look back at this dev process, test-driven development was the first movement that really shortened that feedback loop. Back when it was easy, when you're writing your code and it's easy to make changes. Given how effective that was, what if we extend the dev process out to production, where we know it's going to go anyway, but see what learnings we can fold in as we're writing the code before then? What if we shift that observe stage left? By folding observability into our development process, we can get this beautiful virtuous cycle in which we inform every stage of shipping software. And that's how developers get to build up this ops sensibility of, I'm writing this code, and it smells like, ooh, I should watch out for that case. Or I should think about how it's going to behave when that user touches it. Because observability is more than just a set of tools. It's more than just having a certain set of it's more than having a certain set of data. It's about the process and the culture of a team practiced at looking at code all the way through that cycle. OK, so we're bought in, hopefully. We've set the scene. We know the players. Now let's activate our powers. Earlier, when I talked about observability, I used a lot of verbs. understanding, asking. That's because just having a tool or having graphs isn't enough to let you do that powerful thing. Same way having Thor's hammer doesn't actually make you Thor. So sometimes there are some things that we have to do to really empower and make it easier for our developers to get comfortable in production. The first thing is teach those production tools to speak our language. And when tools speak my language, I mean things like they respect the nouns that I care about when I'm debugging or analyzing code. Traditional monitoring tools often assume a set of things that don't actually tie back to what I deal with day to day, the concepts I deal with in my code. When I have that ops person come at me frustrated because CPU utilization is up on a certain set of Cassandra nodes, doesn't actually tell me where to start looking. It doesn't help me map what she's seeing to what I need to fix to improve the situation. Contrast that instead to the sorts of nouns that appear in my tests, in my day-to-day, that actually trigger different behaviors in the code itself, that aren't just symptoms, but start to be things that let me understand how to reproduce, understand how to let me tease apart what's happening. And imagine, instead of being yelled at about Cassandra write throughput, I'm instead told that the latest deploy seemed to increase latency for our payments endpoint and is significantly impacting our largest customer. Oh, OK. Now I start to understand where to begin looking, how to begin reconstructing that repro, and also what its impact is. High cardinality data support is also important. For anyone who may not be familiar, high cardinality refers to having lots of possible values for a given type of data. And if these are the nouns I deal with day to day, all of these are high cardinality. All of these might have tons of unique values. And a lot of tools, traditional monitoring tools, struggle to support that. But I need these in order to slice and dice and really understand, well, things are slow for this customer. Things are slow for this endpoint under these conditions. Ground this in reality, build ID. Doesn't really seem like a high cardinality attribute. Doesn't seem like an unmanageable type of data. But it's constantly increasing. There's really no bounds on how many builds you can ship. But it matters so much day to day in understanding the impact of my code. This is our dog food instance, and the question that our engineers have encoded in as just one of the kind of templates is my change out yet? Because if they're going to understand the impact of their code, they need to know whether their change has been shipped. And if our software is going to constantly evolve and grow, our instrumentation needs to be able to grow along with it. We expect folks to keep their tests and documentation up to date. Instrumentation is just another form of expressing what this code is doing. We know that the easier we make it to write and run pre-production tests, the more folks will do it. And the same is true of instrumentation. All of these things lead to being more comfortable looking at production, thinking about production, always having that in your mind of the extension of the development process. And in doing so, allows production to not feel like some dark, scary place. So that your legacy monolith doesn't feel like some impenetrable thing that is behaving in a strange way. No, it's just part of how we ship code and how we understand how it behaves. We talk a lot about nouns, speaking the language. There's some concepts that we can bring from production into development as well to make it feel more familiar. Tracing is one of the most developer-friendly evolutions yet in this industry. A lot of people talk about distributed tracing. It's great for it's great for microservices. When you have containers and Kubernetes, it's important. That's cool. That's true. But it's also great for just understanding what's happening inside one service, inside my logic. One look at a trace, and you immediately start to understand how it maps to the structure of the code and how it's executing. Someone described tracing recently as Chrome developer tools for non-browser software, which feels a little silly, but is so accurate, right? Also, teaches you that none of these concepts are ever new. But how exciting that we can start to connect these things that developers are totally familiar with, they understand how to look at, they understand how to work with, to this production environment. Where, hey, this thing that you're used to be able to doing inside your browser for this one request, you can now do for this thing that executed in the wild, for this user over there. You can see service boundaries, you can see function boundaries. And once you have that developer happily looking at a production trace, thinking about, oh man, okay, here's just like some weird things that happened with that user, you've got them. And you can start to show them the overall impact. To be like, oh yeah, this thing that you're looking at that happened in production, here's where it is relative to everything else in production. This trace that we're looking at, oh, this is unusually slow. Okay, what can we learn from it? And understanding its impact in production overall. I also love tracing because I feel like it's found a really clever way to make logs tractable and meaningful. All devs know how to log, right? Printf, hello world, one of the first things that we do in whatever language you prefer. But adding a little bit of tracing structure lets you start to turn those log lines into something that actually reflects the code, which feeds into better analytics, which feeds into better understanding of production. And I feel like tracing is what happens when logs grow up. So, okay. What does this all actually look like? We've activated our powers, we know they're developers. How does this virtuous cycle help me be better at what I care about most, which is shipping code? A few examples. When observability is our superpower, we can use our understandings from production to figure out what code to write in the first place. One of the oldest problems known to software, right? Something's slow. All right. Users complaining, don't know why. What's slow? Is everything slow? Are some things slow for certain users? Are some things slow in some parts of our system? In dev, maybe you connect a profiler, maybe you connect a debugger, something that like hooks right into your nice little neat sanitary environment. Try to painstakingly reproduce what the user is seeing. But if you have data flowing from production, if you're capturing something about what users are actually experiencing, let's just go there and take a look at what users are seeing. And at that point, it's just a matter of starting from this high-level signal that something is up, right? Some graph that has an artifact where you're like, oh, it shouldn't look like that. You start at a high level, and you zoom in. And you zoom in, you sift apart, you tease apart the signal from the noise, you slice and dice until you find something that you're like, oh, this teal line, that's behaving unusually. Let's zoom in on that. Let's investigate. I've reduced the search space. I, as a developer, can start to understand what cases are causing that slowness, what I am going to need to fix coming up. And then we zoom in, we find an actual example, and we iterate. By being able to do this slicing and dicing, to be able to base it on real production data, we can stop guessing, right? There's nothing worse than spending a bunch of time working on something, deploying it, and not actually seeing it fix the issue. So by having the expectation be, we look at production, we ground our assumptions in reality, we can make sure that we're writing the right code to begin with. When observability is our superpower, not just what, but we know we can learn how best to write that code in the first place. Sometimes you get a simple ticket, right? Handled nested JSON. Great, easy. I can do that. I can write the code, write a test case, push it out. But wait. Is this actually is your code going to do what you actually want it to do? How many users are using your system right now and relying on the old behavior? Well, your new code impact them in a way that they want? How many people are actually using your system the way that you expect? Being able to use production data to understand what normal is a hugely important part of making sure that the code you ship does what you expect. Or else maybe you start unfurling a lot of JSON that people didn't actually want unfurled. What if, instead of jumping right in, writing that code, writing the test and shipping it, what if we had a little bit of instrumentation? Or what if we looked at production, if it was already instrumented, to see how many people are using, how many people are sending us nested JSON today, how many people are happy about that? Instrumentation allows us to turn the kind of data exhaust that our systems output into these lightweight debug statements. It helps us understand what the code is doing along the way. And being able to do that in real time, having that flexibility to ask, well, what's it doing? That's what helps us understand what things are edge cases, what things are edge cases that matter for our tests, and which edge cases are actually the norm, and our mental model of what people are doing is mistaken. Occasionally, I have someone be like, well, that's what product managers do. And this is true. Product managers do a lot of thinking about what is normal and what users want. But often, they're making their decision, and these are grand assumptions, I apologize. Many product managers make their decisions based on qualitative interviews and grand intuition. Screw that. We're developers. We have access to production, and we have real data. When observability is our superpower, we can look at production to figure out whether our code is working and whether our code will work. Complex systems have an almost infinite set of possible failure scenarios, or possible but almost impossible. As they get more complex, the set of those simply increases. And so rather than trying to predict each one of those and immortalizing it in a test, in a pre-production environment, by embracing observability, we are able to make sure that if something happens, we find out about it immediately, and we have enough information to do something about it, to learn about it. By tracking the signals that we need at the top, and including the metadata that we need to break it down, we can tease apart the interesting bits in real time and have that feedback loop back into, well, I see in the code how to reproduce this. I can see in the code why it executed down this path. Test in production has become kind of a polarizing term for some folks. So first, let me say, when I say test in production, obviously, also test pre-production. But what I love about the phrase is that it's all about having production be a testbed for hypotheses, for code that you're like, this should work, but it might not work, so let's make sure. Our friends over at GeckoBoard have a great story where they were releasing they were working on a feature that essentially reduced down to the bin packing problem. And like any NP hard or NP complete problem, it could have been something that their engineers jumped on and been like, I'm going to spend a couple days coming up with the perfect implementation of this, you'll see. But instead, they were like, wait, we can test this. Let's come up with a couple different implementations. Real quick, don't spend much time on them. Push them all to production. Have production traffic flowing over them, then throw away the result after capturing it in some sort of observability tool where they could slice and dice and quickly assess which ones worked best on their workload for their customers in reality, not just some hypothetical test environment. And they were able to do that, assess, pick one, all over the course of a day because their tools supported ad hoc experiments. Their culture was one that wanted to be data-driven, is data-driven, and their developers were comfortable with the idea of production as a test bed. The idea of, well, I can't simulate, there's only so much I can do before production. Let's see what's happening out there. And my favorite part, I think, of this particular superpower is how well it pairs with other techniques that people are adopting in this space. Feature flags are great. They make it really easy to test out code on a very specific segment of your traffic. It's even more powerful when you can take that segmenting, where you can take the values that those feature flags are outputting and shove them into your observability tooling. Because then you can see your top-level metrics that you care about, latency, throughput, error rate, whatever you care about, but also break it down by whatever tiny segment of folks are flagged in that day. Example with this, a couple years ago, we were, every time we ship out something that is going to touch a very performance-sensitive part of our system, we try to ship it out behind a feature flag, right? So because we know the performance-sensitive part of our system deals with a lot of heterogeneous traffic. We can only simulate so many things in test. We push it up very carefully to production, and we use a feature flag to double-check, OK, this change should have no impact on performance. We've flagged in this 3% of our users. Is that true? Do our expectations match reality? And we can see latency for folks flagged into the experiment, not flagged into the experiment, and have confidence that that test code, this almost there, mostly covered, but possibly problematic code, we can see for sure in production, great, it's stable, let's ship it. And to return to a previous theme, if the Marvel Universe has taught us anything, it's that superheroes are better together. When we're trying to understand something about our systems, especially if we're new to a team, the best way is always going to be, hey, how did you do that? How did you figure that out? When our best resources are teammates, it's because they have the context to know what matters and what doesn't. They have the context to look at a graph and be like, wait, break it down by customer. That customer, they're garbage, we can blacklist them. And realistically, I am just never going to be as good at debugging a Kafka issue as the ops person who's been dealing with Kafka for the last 5 years. But if I can peek over their shoulder, and if practices, tools, processes make it easy for me to borrow that knowledge, it's a whole lot better than trying to figure it out myself. And honestly, let's face it, all debugging is social, even if it's just past you, present you, and future you. Sharing context, like the little notes to yourself or the little hints about how to interpret a graph, that context is key when understanding whether something matters. It's the context and knowledge that lives in our brains that takes data from being just data to real answers. A lot of the techniques that we use in this industry to transfer knowledge, docs and postmortems, rely on active intent and active knowledge transfer, which is good and important, and we should continue doing those. But it's also important to recognize the value of passive knowledge transfer. Chat ops, Slack bots are kind of in this space. But imagine if tools, the things that we're using, allow us to leave a paper trail for our future selves or our teammates. If I don't need the resident Mongo expert to teach me something, and I can instead look through their paper trail, see how they resolved some issue when they were on call last week, it allows them to show their work without having to worry about me, and me being able to level up on my own time. I've heard engineers new to an on-call rotation describe watching an experienced on-call engineer like watching someone make leaps of intuition akin to magic. But as we know from Arthur C. Clarke's third law, sometimes all that magic is someone using sufficiently advanced technology. And the key for us is finding a way for folks to use that technology in a way that is learnable and shareable. This is how we build up our superhero team. This is how we lower the barrier to entry for developers just getting comfortable in production. And this is how we bring everyone up to the level of the best debugger. Now, while we segue into the obligatory Batman brooding over Gotham City moment, let's recap. In the old world, devs cared about code in the development and test environments, and ops cared about prod. But there are all sorts of reasons to break down those barriers now and empower devs to own their code through production. There's some concrete things we, on the dev and the ops side, should be doing to facilitate that. And we can take our learnings from production and supercharge our development process. And in the best case, honestly, we skip the expensive CGI battle. And this is where reality deviates from Hollywood. Because the whole purpose of this exercise is to reduce that sort of tension and release. To reduce the number of times that we're woken up in the middle of the night because our code is misbehaving. When we fold observability into the development process, we can ship code more reliably and more confidently because we know that we've already thought through some of the production cases, because we may have already even tested it in production. Because no one can live the ups and downs of constantly being on call, constantly being paged, constantly being pulled into battle. And the more that we can do to shift those high-stress situations from reactive behaviors into proactive work that thinks through expected versus actual, the more we'll be able to be resilient and do what we love, shipping code. So for those folks in the audience who raise their hands when I ask whether you're an ops, infra, DevOps, think about how you can empower your devs to share in the great responsibility and the great power. Think about the tools and processes that let developers start to build an understanding of, I have this code, I tested this code, I shipped this code, and then it did this, and then it behaved like that. And look for opportunities to show developers the sorts of powers that they can have and how observability can help them even before they hit merge. And if you're a developer, remember that these superpowers are possible within your grasp, because we need to stop writing software based on our intuition or someone else's intuition and start grounding it in reality and backing it up with data. Because we can all have superpowers now. When we look for opportunities to get comfortable with production, we'll ship better code, deliver better experiences, and observability will genuinely be how we got there. I've got a little bit of time. I'd love to take questions. Thank you for being a great audience. Yes?
I'm live blogging you as well.
Thank you.
So that's why I was taking pictures. How do we answer compliance when we're living still in enterprise land in corporate America and it says, devs can't touch prod, you have to be separate. And I know that we're getting there, and there's a way to get there. Your hints would be greatly helpful for those of us in corporate America.
The question was about compliance and about what happened, how to facilitate this feedback cycle when there are rules like devs can't touch prod. Well, what does touch prod mean?
And
right?
automation is the answer, quite honestly. Like, you automate it and you don't touch it. But how do we explain this better in our compliance space when we've got people that are 5 years behind the technology?
Okay. The question was, how do we, automation is the answer, but how do we explain the difference between that we're not touching prod? Well, I don't know if how this will go with your compliance folks, but there's write versus read, right? If they're worried about the writes, a lot of this observability stuff, a lot of this is just read. Let's make sure that we have ways to read what's happening, and that reading is what's important. And I feel like if you can frame it in a way that says, like, this reading of signals from how our code behaves lets us detect problems sooner or prevent problems in the first place, like, that has to be something that they can get behind. They don't want problems either. They don't want there to be issues either. But there needs to be that visibility into what's happening, or else you're relying on your users to do that for you, and No one wants that. Yep.
How would you adapt these ideas to a product where you don't have a lot of production traffic or meaningful data on front?
Question is, how do we adapt these ideas to a product where there isn't a lot of meaningful production traffic? Is that about? I think there's a perception that these techniques are only useful for super high volume systems. I don't think that's true. I think that for anything where you are taking software that you deeply understand and then putting it into an environment where it might be used in a way that you don't deeply understand, it's important to have that feedback loop for how it is being used, how people, the inputs that people are putting in. A lot of folks will say, well, I have exception trackers for that, and exception trackers will tell me if someone did something that I didn't expect, which is true insofar as everything you didn't expect will throw an exception, which isn't always the case, right? I think that the idea that I'm trying to get in folks' heads here is that feedback loops are necessary at every stage. They're necessary for your hobby project that your friends are using, but might be using in unexpected ways, and you can create feedback loops looping into everything that you do. Does that answer your question? I don't know. If you ship a side project, you should have something that tells you whether people are using it. Yeah.
How do you advocate for instrumentation as an essential in an agile or lean environment where it's a nice to have, not an essential. We don't need this.
The question is, how do you advocate for instrumentation in an environment where it's thought of as a nice to have? Otherwise known as life, yeah.
We're still trying to sell it to our bosses.
So it can depend, right? There are a few arguments I made where I'm like, well, instrumentation is like tests. Like, you like tests, right? We want instrumentation. That can go well. They might not buy that. I think it is, and sometimes it's selling to your bosses. Sometimes, as an ops person, it's selling to the developers, right? Developers don't want to be slowed down. They don't want to add instrumentation. The argument I always use is like, well, assuming you're not starting from nothing, like show them what you can do when you get there. Show them the value of, oh man, if we add customer ID to this graph, we can immediately see this thing. We can immediately understand that this one customer does this terrible thing all the time, or that things are slow, but for this one customer, it's way slower than everyone else. And finding, like, there's often just a little bit that we can do to speak in the language of what they care about that starts to get some head nodding, to be like, oh, okay, that's not so bad. And there's also this perception that instrumentation is like a big, heavy lift that must be done correctly all the way through, and it's a whole project unto itself. But that doesn't have to be the case either. It should be incremental. It should be something that evolves with the code that you're shipping. And the more that folks can get in the mindset of, oh, well, I'm writing this new code. Do I need to update docs? Here's this instrumentation that I should make sure matches this other stuff over there. Again, you start to get that dopamine hit of you add a little bit of instrumentation, you use it for some benefit, and it gets ingrained into your practice. Yeah.
If you're working somewhere and you feel like you've got some instrumentation tools, you've got your Datadog, you have your New Relic, you have your Splunk, you're all happy with this stuff, what are some questions that you can kind of ask yourself, like, do we know X, or can we see, what are some of those areas of questions to kind of test whether you're doing this well?
The question was, if you are in a land where you have some instrumentation, you have some tooling, how do you gauge whether you're doing it right or doing it well? My question back to you is, like, do you ever have outages or incidents or questions where you're like, I don't know the answer? Which is a very squishy answer to your question. But if you exist in an environment where you've got some instrumentation, usually when you have questions about what's happening in production, you can answer them in a way that is then actionable, awesome. You're set, seems stable. If you have all of these tools, and yet when you have downtime, you can't figure out why, or you can't isolate it, you can't figure out where it's happening in order to stop the bleeding, those are signals that something's not right. Right? It's easy to have, especially in this day and age, it's easy to have like 5 different tools that all promise to do the same thing, and yet have none of them give you the answers. And I think one of the most frustrating things from my past lives is like having a graph and being like, I see this, but why? Like, tell me more. And that feeling is one where there are a lot of really great flexible tools out there that can let you explore in a way that answers your questions. Yes?
Yeah, I liked your talk. I noticed when you had environments, you had dev and prime. Do you think UAT is worthwhile or it's a waste of time?
The question was whether I think UAT is a waste of time, and I'm actually going to have to say I don't know what UAT stands for.
User acceptance tests. Environment you deploy to before going to prime.
UAT, user acceptance tests. Do I think that's valuable? It can. That's part of your process. The thing that I love within that is the idea that there are end users who are testing it. Not, they don't care about your unit tests passing. They don't care about your functional tests. They care about their goals. The thing I'd push back on there is still, is that going to get you coverage in the way that you care about? How did you pick those users who are doing the user acceptance testing? How did you pick the cases that they're going to be testing for? It seems useful, but it still seems like it relies on a lot of predicting what will matter, and we're moving towards a world where you just can't anymore. So basically a decision for your team whether you want to maintain that environment or not. And I think a trend that we're sort of seeing is folks getting rid of their staging environments because they're just like, well, we have the visibility that we need in prod. We don't need staging anymore. We don't need this intermediate environment because it's just overhead. Any other questions? Yes, sorry about that. Thank you for that. The comment was to add to the question of how do you incentivize people to care or add instrumentation or better their world. Some teams put their developers on call, and that's certainly something that we've seen as well. By putting the people who create the problems on call for their own software, when you're woken up at 2 a.m., you have to deal with figuring out why it's happening. Absolutely. Yes?
Just want to pile on to his suggestion and say one thing that we observed that made observability a priority in our organization is actually putting our leaders on call. So we have a leader on call who's responsible for communicating out to the organization what's gone wrong and why. And once you have both devs and leaders on call rotation, you've got managers, directors, and VPs getting at 2 a.m. Those priorities really
The additional comment was, in addition to putting developers on call, putting leaders on call. When managers and directors start to get paged, start observability and better tooling around that also becomes a priority. Thank you. All right. I will be around if anyone else has questions. Otherwise, please go to lunch, get fed. Thank you for being a great audience.